Uh, well, when we create the BHT file, we create 8 events that in each one event we put different inputs in the ins in the others yeah, in the enters, I don't know. In the variables is fair. In the variables you need to select the time of the simulation. For our case is 80 nanoseconds, and then you only need to click here in run. You see this at first because the visual is very zoom in, okay, and then you need to click right click, and you can click in full, and you can see all this simulation. With this you can insert a cursor, and you can see here what is the logic level of each one of the variables. Okay, in this case, like is another, when y is 1, the output is 1. When x is 1, the output is 1 as well. When the two x and y are 1, the sum, the add of that is making a 2. No, for that is carry out is 1 because we have an overload. Then we have carrying like 1 and x and y in 0. That is an add. We can see that 1 plus 0 plus 0 is a 1, and the original output is 0. No, it is 1. Yeah, I repeat it. I have carrying like 1. Okay, we have 1 plus 0 plus 0 is 1, and the finally result is 1. Okay, yeah. This is yeah, for finally we have all the stuff in 1. It is 1 plus 1 plus 1 is the number in binary 3. No, but here we can 3. We have overload for the carry out is 1, and the output is 1. That's it, the complete truth table of this practice. Okay, when you have this, you practically finally, no, you practically are in the final part. Well, this only helps us to see if we do well the project to what we wanna do. Okay, then we can close this window. Yeah, with all the problems to need to create a window. No, we close it. Yeah, now we need to select our pins of the physical board. Eso, developing board. Again, because I have this ugly situation of the colors wanna see nothing. Okay, now for this for the DE10 Lite FPGA is I have here well, here I have here the tables. Okay, is faster to name the tables. Yeah, here. To see auto switchers and LEDs. Here we have the table of the switches. Okay, we have pin C10, 11 and D12 for the first three switches, and that we want to use, okay, for our inputs. Okay, you can type pin, then you can click on the arrow to the right to complete, and then you can only change for the pin that you want to use, like is the first the 10. Oh, see, okay, maybe this is better that to be D12, okay, because seeing is better to understand the things. Is this is the pin for the switch number 3, okay, that's stop. Oh. Then enter, and you can see the fucking table is another color. I can see anything. Okay, now pin here is C10, yeah, and why wanna see pin C11, okay. Then we have the outputs. The outputs need to be the LEDs, and I have here the other table. Only this is this side. We have the LED 0 and 1 is A8 and A9. Okay, and here we can put the original output like pin A8, and the carry for pin no. Pin A9. For me, for check is all good. I do like this. Okay, select to see well what is I doing. I think is a good pin planner. For my first input is X, then is Y, then is carry in, and the output says the first is the output original output, and the carry out like this. You don't need to do anything more. You only close, then the close return to quartus. Again we need to start the compilation, to take our FPGA, put it their communication cable wire, cable don't exist, wire, and when this finish I wanna connect my FPGA, but for you to see the final result I need to make other video. And this video only wanna see the workspace of my quartus, or yeah, and the other video wanna upload the final result of this, okay, because well, maybe I can make it the 2 videos in one, I don't know, depends the YouTube, okay. Wanna disconnect this, my mouse, okay, wanna connect my yay. The only thing that you need to know before this is you need to actualize their drivers. Okay, for that you can okay, like, well, this button is to program. Okay, when you click on it, we're gonna appear the program window. Okay, yeah, this program window. If you don't have the drivers here and hardware setup, you never gonna see UCB blaster. Okay, you need to upload the drivers to use UCB blaster. If you know, only you wanna have this option that don't not hardware, but in my case I I have actualized. I don't. Yeah. Well, you select and add this hardware, then close, and only you need to, for continue, you only need to click on start, and then when the progress is successful, my my board is ready to work, and that's it. The moment. This is the part of the physical proof implementation on the board of the DE10 Lite. Yeah, it's about the project of the full author. You can see we have the three first switches are um, X, Y, and carry 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 in. Yeah. Then we have here our original output, and this one is for carry out. Okay, you can see that with one is 1 plus 0 is 1, no? With one add other one is 1 plus 1 is overload, and the carry out is going on to turn off, no? And then you can see that this doesn't matter what is the first of the three ones to get a 1. Yeah, here we have x and 0 and y and 0, and carrying like 1, and then we have 1, no? Then carrying plus x with 1 is 2, and that is overload. And then if we have all on, we have one for the original output and one for carry out. Yeah, like it's a tree, binary tree. Okay, this is all. Thank you for watching.